Hey everyone, welcome back to Programming Horizons. Today we are going to explore Pandas, one of the most powerful Python libraries for handling, manipulating and analyzing data. We will cover the basics including series, data frames and some useful operations. So let's open up Google Colab or your favorite IDE and get started. So here I am inside Google Colab and I am clicking on New Notebook. And here we have got our new notebook. We can rename it. Let's say I am naming it as Pandas Basics. And now we are good to go. So guys, inside the Google Colab notebook, we can increase the font size. We will click on Tools, go to Settings, click on Editor, and then we will select the font size as, let's say it's 28. This will make it easier for you to read the code. So first of all, let us understand what is Pandas. You can think of Pandas as a more powerful version of Excel that works inside Python. To install Pandas, we just need to run this code pip install pandas, and if I run this code, then you will see here is a message requirement already satisfied. That's because Google Colab comes pre-installed with Pandas, so I don't need to install it separately. But in case you are using a different IDE, then just type this command and run it, and Pandas library will be installed on your system. So in my notebook, I am just going to import Pandas with an alias as PD, and PD is the short name for Pandas. So instead of typing Pandas everywhere, I will just type PD. Right now Pandas has been imported into my file. So before we begin, let's see what is a series. A series is like a column of data, a one-dimensional labeled array. Now I am going to show you how to create a series. Let us suppose that we have a list of fruit names like this. Say apple, banana and cherry. These are the three fruit names that I am having. Now in order to create a series, I will have to declare a variable first. Let's say S is the name of the variable. To this variable, I will assign pd.series, and then I will pass here the list name, which is fruits, and in the next line I will print S, run the code, and here you can see, I'll zoom it for you. A series is created which looks like a single column with an index on the left and values on the right, and index begins with 0. If we want, we can also create or use a custom index. Let's do it. So once again I am clicking on code, and now I will type here S equal to pd.series, and then I will pass the name of the list, which is fruits, comma, index equal to, and this index parameter will accept a list of index values. So let's say my index values are 1, 2 and 3, and these have to be passed in the form of a list. And after that I will type print S, run the cell, and this time you can see here that the index values have been applied as 1, 2 and 3, which I have just passed, and the values are on the right hand side once again. Let's move on and learn about creating data frames. A data frame is a table that has rows and columns, just like an Excel sheet. Here we are going to create a data frame from a dictionary. Let's suppose the name of my dictionary is persons, and inside this I have certain key value pairs. Let's say the first key is name, and after that I will pass here a list of names. Let's say Alex, then Bob and Chris. These are the three names. I will put a comma afterwards, pass the name of another key, which is age. Once again I will put a colon mark, and then I will pass a list of numbers to represent age of all these three people, and let's say the ages are 35, 32 and 28. Then I will put a comma again, and this time I will pass here the third key as city, and here I will pass New York as the first city, put a comma, and then I will pass London, and last city is Paris. Alright, my dictionary is now created. So I will have to create a data frame from this dictionary, what I will do, I will pass here the name of a variable, let's call it as df, and then I will type pd.DataFrame, put here a set of parentheses, pass the name of the dictionary which is persons, and let's run the code. Okay, I have to display it first before running the code. So now I will print df and run the code, and this time a data frame is created. As you can see, all the values are arranged in the form of rows and columns. Now let's understand some basic operations in Pandas data frames. The first operation that I am going to show you is used to access a column of a data frame. Let us suppose that I want to grab all the city names from inside this data frame. Then I will type here print df and pass here the name of the column city, run the cell. So I have got all the city names in the form of a series. In the same way, you can access any particular column of a data frame, and therefore we can say that a data frame is a collection of multiple series. Try accessing the name or age column in the same way. Now let me show you how to access a particular row of the data frame. Let's suppose I want to grab this row at index 0, then I will use the loc method. So I'll scroll down here and we are going to access a row using loc. So what I am going to do, I will type here print df.loc, and inside a pair of square brackets I will pass the row index 0. Run the cell, and here we have got the first row in the form of a series. Notice that the index 0, 1 and 2 have been replaced by the column name. Now suppose that I want to access the top 2 rows, then I will put a colon mark here and pass here the index of the second row as well, which is 1. Run the cell, and this time I have got the top 2 rows. Right. If I want to grab only the age column of the top 2 rows, then I will put a comma here and pass here the name of the column, which is age. Run the cell, and this time I have got only the age column's values for the top 2 rows. We can also access a row using iloc method. So I am going to create a new cell, and this time we will use iloc method. I will print here df.iloc, and then after that I will pass the index of, let's say, the second row, which is 1. Run the cell, and this time I have got the second row's values in the form of a series, as you can see. Now let's suppose that I only want to grab the value of age column for this particular row. Then instead of passing the name of the column, I will simply pass the index of the column. So index will begin with 0, 1 and so on. So the age is at index 1. We will run the cell, and I have got 32 as the value. Let's see, let's confirm if it is the correct value. Yes, Bob has age 32. If you want, you can also update a particular value using loc method. So let me first print the data frame values. So I'll simply print it, and let's suppose I want to change the age of Alex from 35 to 36. Then in that case, it is very easy to update it using loc method. I will simply type df.loc, pass here the index of the row, which is 0, and the name of the column, which is age, that I am updating, and I will assign it the new value, which is 36. Run the cell, and it's done. If you now print the data frame, then you will see the updated value. So yes, we have got the updated value. 35 has been replaced by 36. Let us now understand how to filter data using conditions. Let's suppose that I want to display only the rows with age greater than 30. Then in that case, I will type here print df, and inside a pair of square brackets I will pass the data frame's name again, and after that I will pass the column on which I am applying the condition, and then I will check if the age is greater than 30, and then I'll run the cell. So I have got 2 rows with age greater than 30. So I am giving you a small challenge. Try accessing the row with city equal to London. Okay everyone, Let's suppose that I want to sort the data according to ascending order of age. Then in that case, I will pass here df.sortValues method, and this is an inbuilt method which accepts the name of the column by which we are going to sort the data. Let's suppose in this case we have age as the column by which I am sorting the data, and if I do not pass any other parameter and simply run the cell, then you can see that the rows have been sorted in ascending order of age. But in case you want to sort it according to descending order of age, then pass another parameter which is ascending, which is by default true. That's why I did not pass it the first time, but here I want to keep it as false because I am applying a descending order, and here is the updated data frame. Now that you know how to work with series and data frames, let's take a look at how to save and load data using Pandas. So first of all, I am going to save this data frame to a CSV file, and in order to do so, I will click on code. Here I will type df.to_csv and then pass the name with which I want to save this data frame as a CSV file. Right now I want to save it as persons.csv and run the cell. Go to this folder, and here you can see a CSV file named persons has been created. Now if you want, you can download it to your system. See, the file has been downloaded to my system, and if I open it, I have got all these values. Right. If you don't want this index by default, then make sure that before running this line, you have to pass here index equal to false. Run the cell, and this time persons.csv has been created, and there is no index as you can see. I have just double clicked this file and it has opened over here. Now if you want, you can download it again and check it inside Excel whether index is there or not. And that's all for part 1 of my Pandas basic series. Here we covered how to create series and data frames, select and filter data, sorting values, and how to write CSV files, all using simple hands-on examples. In part 2, we will take a look at how to load a CSV file and explore a real data set. So stay tuned. If you found this video helpful, then don't forget to share it with your friends. Also, like and comment on this video and subscribe my channel Programming Horizons for more videos like this.